Hi everyone, welcome back to my channel. This is the 7th of a series of basic Python programming course. I'm Sarjun and you can call me Sarj. I'm a data scientist, a data science trainer, and a mentor to the youth. So before we start, I would like to seek your understanding to help me with my socials as I'm trying to reach out to as many people as possible. Facebook, Instagram, YouTube, Twitter, subscribe, send me a DM, and I'll get back to you as soon as possible. Thank you. Let's get into today's lecture. Okay, so you should be able to see my screen. Yes, today we are going to be looking at list variables and manipulation, right? You should know how to get to this using the Anaconda prompt, right? Okay, let me get my, okay, so we are in, correct? Okay, yep, that's what it is. Okay, so list variable and manipulation. List variables are useful for storing a sequence of data in a single node. Lists can be accessed and manipulated to achieve the required outputs. A list provides users with the option to store different types of variables within the sequence variable. Okay, so this is pretty much what actually sequence list can do a lot of things because it's a very useful sequence variable, right? So some characteristics about list. List is heterogeneous, right? Can have duplicates, can be changed. The elements are separated by a comma. The elements are enclosed in a parentheses. Supports appending, concatenation, indexing, and slicing. Minimum, maximum, and length. Especially minimum, maximum, you need all of them to be numerals. In and not in options, as well as a list variables is also a sequence. So sequence operations can also be applied to it. Okay, now let's get right to doing some quick examples. So let's create a list variable called book list. So book list equals to, I'm going to be just copying this and pasting it because I don't want to type it out, right? And then we are supposed to display book list and the data type for book list. And it's not a surprise. You all should know that a data type is actually a list variable, right? When we run it, you can see it prints out the 3 different elements and it's a list variable, right? So now create 2 lists, okay? Book list ds, right? I'm going to copy this 3. I'm going to paste it here, and I'm supposed to create ds is small s. No, I want it to be capital S. Okay, now book list novels, right, equals to this books: Lord of the Rings, Harry Potter, and Hardy Boys, right? Okay, now let's use the plus operator and concatenate them and assign them to a new book list library equals to book list ds plus book list novels, and display again. I'm going to display print book list library and print the type of book list library. Okay, and close this. Again, it makes everything into one list. You can see earlier we had 3. Now it added another 3 more and makes it 6 list element, and this is a list variable. Moving on, let's append a list in the list variable. So let's create a list variable called book list novels is equals to this, right? And then append using the append method, sorry. So let's do a book list novels dot append equals to Jumanji, and then display the variable print book, list, novel, right? Oops, else S novels, right? So you have this tree, so you added the element Jumanji in it. Okay, we can also sort elements, okay, but they need to be they need to be of all same data types. Later we'll see an example where if they are not of the same data types, there are some issues, right? So let's try this. Okay, let's try this. Let's create a list variable called average prices equals to this, right? And then we're going to sort this. So we're going to use a sort method, and we don't have to assign it back because it's kind of automatic when you use list. So you just put sort in this manner, average prices dot sort, and then you just display print AVG prices. Right? You can see that it's actually sorted 19, 24, 38, 43, 99, 155. You can also use the sorted function, which is slightly a bit different. So let me copy this. And when I use the function, I need to create a new variable. So AVG prices sorted is equals to sorted average prices, and I want to set reverse equals to true, and then I want to display this. So this will do it in descending order. So let me print G prices sorted. You can see it's in descending order, and it's the same. It works perfectly, right? So it's good. Okay, let's check the presence of an element in the list variable. So let's do this. Let's create products equals to this, and see if we want to check if dairy is in, using the in operator, is in products. So let's do this. Print dairy in products, right? It's true, right? Okay. Similarly, we can do average prices. We can set it to this, and we can check whether 24 is in this average prices. So we can print 24 in AVG prices, right? Again, it's true, right? So it's quite simple. You can use the in function to check whether it's in. Now, you're going to take 5 minutes. We're going to see whether we're going to create a list variable average prices. We're going to check if the list variable average prices does not contain the element. So does not, so does not means it's not the same as in. So does not contain the element within it. So try it. Take 5 minutes to try it out, and then we will go through. Okay, let's see how to answer this quick practice session. Let's create a variable average prices equals to, so these are the values. I'm going to paste it inside here. Okay. And there's a trick here. We're going to print 99 not in average prices, right? Because the question is asking to check 99 in average price or not. It's not in, it's false. Okay, moving on. We're going to look at list manipulation, things like simple list methods, extend, insertion and removal, indexing and slicing. So simple list methods, we're going to be looking at number of elements in the list, count the number of occurrence of a specific element in the list, maximum and minimum values of a list of numerals, remove, sorting, reversing, append, copying, and assignment. Right, so let's start off with looking at a list variable. Let's create product prices equals to this value, this set of values inside this list. Let's display the length. So print the string. The length is len product prices. Okay, and I also need to print the variable. Don't forget that. So print the product prices. Yep. Okay. Let's now count the number of times a value or element appears inside the list. Right. So let's create a list variable called product equals to. So I'm going to again copy it. I'm not going to type this out. I'm going to count the number of times. So product. So please do use the print function for myself because I'm just showing it to you. So I'm not going to use the print function, but you're advised strongly to use the print function. Okay. So you see that number of times bakery occurs in this list variable twice. So it's 2 times. Similarly, you can also do it with numbers. Retail products equals to this value. We're going to count the number of times 8 occurs here. So retail products .count 8 is 3 times, right? Okay. Again, we're going to assign product prices with these values. What's the maximum value? Just put a max, pass in product prices. It's 890. What's the minimum value? Min, same thing, right? Product prices. Remember, they are all in numeric, so it's easy to do this. If not, it might not be possible. So let's see an example where it's not possible, right? So we do product prices. We pass in a set of mixed data types values inside it. And we try to find the maximum value. It actually throws an error because you can't compare between a string and an integer variable. Right? So let's move on. The removal of all of the elements in the list is basically, so let's create a variable called products of all these values. Simple, right? And then we print it out first. The list before, or this, let me put it, this is not this is printed first. I said, I call it products, right? And then I do the products.clear, and then I print it again. Print it after clearing the list variable value, right? So you can see after I clear it, the list variable is now clear. There's nothing here. We can also do a sorting of the list variable, right? So let's call this product price equals to all these values. I can do a product price dot sort. I don't have to reassign it because it auto reassigns in the method itself. You can see sorry, I better use a print function, right? You can also use the usage of reverse in the numeric list variable value. right? Similarly, I'm just going to copy this, right? I'm just going to copy this. I'm just going to type in product price dot reverse, and I'm going to print product price. You can see it actually reverses it. Okay, so there's always a common misconception between list reverse and the sort method with the reverse. So there are differences. Okay, the list reverse just reverses it, but the sort reverse actually sorts it and then reverses it, right? So there is definitely a difference, right? I wouldn't say it's a slight difference. It's kind of a big difference, right? So when we display this variable value, right, we can see that it actually does sort it, right? Again, I forgot my print statement. Yeah, it's different from the reverse. Okay, just to be sure about it. Okay, the appending of list of variables to a list of variable. So this is important. Again, retail products equals to, so I'm just going to copy this and I'm going to remove this. I'm going to append retail products dot append, and this time I'm going to append shower cream and cleaning solution, and I'm going to display it. Okay, note that unlike earlier when we added two lists, here we're adding one list and appending another list inside this list. So the catch here is this is the first element, this is the second element, this is the third element. This list itself is the fourth element together. So you need to know there are subtle differences between adding it and appending it, right? Okay, so assign a list variable, retail products. So I'm going to copy it here and paste it. And then I'm going to make a copy of the list variable retail products. I'm going to do a copy. So I'm going to use a dot copy function. So retail products copy equals to retail products dot copy, and I'm going to print both values out. Retail products, I'm also going to print products copy, and I want to see where they are the same. So print and yes, they are the same, right? Now let's try a slightly different version where we're going to assign it without the dot copy function, right? So that's going to be done with, basically I'm going to do exactly this. I'm going to copy this and paste this here. I'm going to copy this and paste this here. And I'm going to do it again, but this time I'm going to call this reference. But this time I'm not going to do it without the copy function. And I'm going to print all three variables. Print retail products I'm going to print the copy, and I'm going to print the reference. You can see they're all the same, right? No difference, right? Now I want to use the append function and add soap to the retail products, right? So let's use retail products dot append SOAP, and I'm going to print all these three again. Watch this carefully, right? You can see that retail products, the soap is appended, but for retail products copy, it's not appended, right? But for retail products reference, it is appended. So because retail product reference is referencing from retail products at, at every time, right? So this is a bit tricky. You need to understand that reference is different from copy. Copy is just one copy, and after that it forgets, it loses the link. It's the value is stored somewhere else now. But for retail products reference, is always referencing back to the retail products at every point of time. This is a bit technical, but don't worry so much. Okay, so let's manually add the element to the retail products copy just to do some quick retail products copy dot append. So now I'm just trying to make them all the same. Okay, so let's print it out just to see that, you know, in terms of outputs and inputs, they're all the same, right? They all have the soap value at the end, right? Let's check equivalence. So if you want to check equivalence, okay, we're going to check whether they're all of the same value, right? So to check equivalence, I'm going to do this. I'm going to do print check retail products versus retail products copy, right? And then retail products equals to retail products copy, right? So this is one. So the next one I want to, oops, sorry. So retail products. I want to do retail products and retail products reference. You know, I can do a plus and minus, right? So I can just plus and minus here. So don't worry, if anything happens, right? I'll make it bigger again. Okay, so I can assign it back to reference. Okay, so retail products and retail products reference. And I also want to do one more. I want to compare retail products copy with retail products reference. Right, so this is copy and this is reference. Now I want to do a one-shot check where I want to check everything is the same. So I also want to check all three variables, right? So this is just basically so actually it's all the same, right? The values are all the same. In fact, everything is the same. All are true, right? So I wasted my time doing this? Well, not exactly. Let's move on to the next portion and I'll show you why, right? Are they in the same object memory? That is something we need to understand, right? Whether they are in the same object memory or not, right? So I'm gonna copy this tree and show you why they are not in the same object memory, right? So instead of using double equals, I use the is function. So is checks whether they are they the same, exactly the same. In terms of value, they are the same, but in terms of where they are stored, amazingly, products versus copy, they are not in the same object memory direction, right? They're not stored in the same place. They're actually stored at different places. But retail products and retail product references, they are stored in the same exact place. Similarly, retail products copy and retail products references are also not connected at all. Because what connects retail products and retail product references? I mean, retail product references is one that's linked to retail products. Retail products copy is on its own, it's separate. Even though the values inside are equivalent, where it's stored and where it's saved is totally different. So this is a very good exercise for you to understand that, right? Similarly, I can also do the same thing with numbers, right? Let me create product prices equals to this whole value here inside of here, right? I can copy the list product to a new list variable called product prices copy. Equals to product prices dot copy, oops, dot, right? And then I want to display both variables. And the copy as well. Okay, I can check equivalence. Basically, print if product prices is equals to product prices copy, and the same thing using the is option. Is checking whether they are equivalent or not. So when I run this, you can see that in terms of equivalence, they are, even though they are the same, because it's a copy, the object memory direction is not the same, right? Versus, let me copy this again. Let me try a product price reference. Just too lazy to type it out again. Okay, let me, instead of copy, I'm going to remove the copy here, and I'm going to just call this product price reference, right? And then I'm going to print, right? And I'm going to do a quick check. Print product price equals to product price reference. This checking equivalence. Same thing, I want to check the direction, memory direction. I just use the word is. Oops, product. There is a slide prices. Sorry, typo. You can see that, what am I doing? Product prices, reference, because of product prices. Let me see, there's a typo here. Product prices. Product prices here. Yes, this is correct. This is product prices. Let me copy this. Sorry, this is S. This is S. Typo error, right? Yes. So I'm assigning product prices with product price reference, right? And because they are not, it's not a copy, they are actually referred to each other. The equivalence and the object memory direction should be the same. Earlier, the reason why it's false because earlier I renamed something called product prices without the S, so it's referring to that. So yeah, that's just a typo. Sometimes you must be careful what you're referring to. Okay, take 5 minutes. We're going to be defining a list variable sale price with these values, and then we're going to do some similar tests as well, and then you're going to display all 3 list variables. Again, similarly, we're going to do a reference versus a copy, right? Yeah, see how they differ. Okay, try out this exercise, and then we will yeah, pause the screen and try this out, and then see what you get. Okay. Okay, let's quickly do this. Okay, let's set sale price equals to this set of values, and I pass this in here, right? And then I assign 2 list variables, house prices and land prices, as reference from these 2 variables. Okay, so now I'm going to set house prices SS. All the way I need S to add S, sorry. S equals to sale prices and land prices equals to sale prices, right? And then I'm going to append 500 to house prices. So house prices dot append 500, and I'm going to print all this tree out. Print sale prices, print house prices, and print land prices. They give me the exact same, right? Now, let's try the same thing. Okay, let me copy this. Right? But I want to set house prices as a copy of sale prices, right? And land prices as a reference, and I'm going to append 500 to house prices only, right? So same thing. I'll copy this and I'll paste this here. So I append house prices dot append. So you can see once that has happened, house prices earlier when I append the house prices, it does append to all. But now because it's a copy, it only appends to itself. It doesn't append to the other portions at all, right? So do be careful of this. We kind of figured this out earlier, but I'm just reiterating it with an example. So list variable extend, insertion, and removal. So extend a list variable with elements. Return an index position of an element object. It's important to understand the difference between list extend versus list append, as they do not result in the same output. Another feature that list has is allows a list variable to be created within the list variable, right? So let's try this. Extend list variable. The extend function extends the current list variable value by adding all items of the specified list variable value. Then create a list variable dairy product. So let's create dairy products. Equals to, let me just copy this and paste this. Right, then I create a new list variable called cheese products equals to these three values. So let's see what list extend and list append do differently, right? So extend the list variable dairy products with cheese products. So dairy products dot extend cheese, wrong spelling, cheese products, and then display the length of list variable dairy products. Okay, print the length is len dairy products, and I'm going to print it as well. Print dairy products. You can see that there are actually 7 elements: 1, 2, 3, 4, 5, 6, 7. So this is what extend does versus what append the list variable. So let's do the same thing. I'm going to copy these values. I'm going to copy these values as well. And this time, instead of extend, I'm going to do an append, right? So I'm going to remove extend and do append, right? And you can see the values will be different, right? This time, the length is 5 because there's only 1, 2, 3, 4, 5 elements, because these 3 elements are taken as one element, right? We did this earlier a bit. I'm just reiterating this point again. So nesting a list within another list, create a list variable m with these elements. So what am I trying to do here? I'm trying to create a list variable m. So m is equals to, so note that there are double brackets. So 1, 2, 3. Okay, I always like to leave spaces, right? And then I do a comma here, right? And then again 4, 5, and 6, right? And then I do a enter again, and then just for aesthetic purposes, make it look better. 7, 8, 9. Yep. Okay, so this M, I can just print M. So I do this and I run this out, right? I print M. So this is what I get, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Printed out, right? So this is nesting a list within another list. So there are actually 3 list elements of 1, 2, 3, 4, 5, 6, 7, 8, 9 within a list variable. And so what you can do is you can actually just type this print M, and obviously this is a list variable, you know that, right? So yeah, let's try this now. Let's do a quick practice. Assign a list variable student list A with Nick, Alfred, and George, and a list variable student list B with Samantha, Caris, and Pamela, right? I think there's a typo error with Samantha's name. It should be 1M, not 2M's, right? And then extend the function on student list A with student list B with student list A, then display the list variable student list B and display out the last element of student list B variable. The second part also does the same thing, but instead of using extend, you're going to be using append, and you're going to see the difference of the outcomes, right? So try it out. Stop and try it out. Stop, play, press stop and try it out. Okay, now let's get into solving this. Student list A equals to these 3 values, right? Okay, student list B is equals to these 3 values, Samantha, Caris, and Pamela. And now what I'm going to do is I'm going to extend. So I'm going to do a student list B dot extend student list A. So it's simple. I'm going to print student list B, and I'm going to print the last element of student list B. The last element, I'm going to use -1 as the last element, the indexing. Right, when I run this, it works. Now, I'm going to do the same thing here as well. This time around, I'm going to use append instead of extend. And when I run it, you can see that the last element is actually Nick, Alfred, and George. It's not George. Okay, moving on. List insertion and removal. Insert a new element to a list at a specified index position, and delete an element from a list variable value. Okay, let's do it. Let's create a variable called products equals to, okay, I'm just going to copy this. This gets the index position of bakery item from the list variable. This returns the lowest index position in case of multiple occurrences. So how do we do that? We use the products.index bakery, right? And give us 1 because 1 is the first occurrence, right? 0 is dairy, 1 is bakery, right? Again, we want to insert a new element at a specified index position. So let's create a variable called products with all these values. Okay, add a new element pasta to a specified index position of 2. How do we do that? We use the insert products dot insert at, not insert, insert at index 2, and I want to add pasta. right? And now the display print products. You can see pasta is now in the second 0, 1, 2 second element place. I can also remove an element from a list using the pop function. So let me add this products equals to, so let me copy this, paste this inside of here, remove this. Okay, then remove the element using the index position of 3 using the pop position. So it's kind of easy, just use pop. Just say pop the third position. By passing 3, you'll just pop out the third element, and when I print out product, you'll see that the third element is popped out. Am I right? Sorry. There's a slight typo here. I'm using products here. I should be using products. Sorry, my bad. Yeah. I was using another product, which is what I initialized earlier. Anyway, so products.pop3 popped out. So let's print it before, just to make it clearer. So before popping and after popping, let's do that. Products. This is before pop method, and this is after pop method. Right? So you can see before is with these 3 values, and then now it pops out the clothing value out. Okay? Okay, with that said, let's do removing the element using the remove method. Okay, so you can use the same. Let's set products equals to, let's set this variable. Okay, I want to add clothing. I want to add grocery, another one more grocery, just to show you how it works, right? And I want to remove grocery. Products dot remove grocery, and I want to display the outcome. So print products. You can see that it has removed the first occurrence of grocery from this. Okay, back to doing a quick practice. You're given 5 minutes, okay, from the list variable average prices with the values as shown. Use the remove method to remove 53.3 from the list variable average prices and insert the value 53 at index position 3 to the list variable average prices. So pause the screen and try it out so that you can get some experience doing this question. Yeah. Okay, getting to answering the question now. Let's see how this is done. Okay, so create a list of average prices with these values. Right, now moving to the next step, I want to remove 53.3. So it's actually quite simple. Average prices dot remove 53.3, and then I want to insert in the third position 55. So avg prices dot insert 3 at 55. That's also done, and I can print out avg prices. And yep, it's done. It has removed 53.3 from my list, and it has inserted 55 at the position where 53.3 was, which is at the third position, right? Simple as that. Okay, indexing and slicing, extracting specific segments of a list variable, right? Use of indexing to extract one specific element, use of slicing to extract one or more specific elements. So use of indexing is with reference to a particular element within a list variable value. When a list variable is created, there are three parameters to referencing this when slicing the list variable. I think this one's quite similar to the string variable as well. We have a start, we have a stop, we have a step. The default for start is 0, stop is the length of the list variable value, and step is default is 1, right? Okay, so indexing. Let's create a products. Products equals to, let me copy this and paste this inside of here and display only the first element. So to display the first element, I think you all know, we just use what we call the products 0. So print products 0. So 0 is the first element, dairy. Simple. Negative indexing. We also have negative indexing. So let's copy this, paste this here, display only the last element. So the last element is just -1. So I'm just going to copy this and I'm going to paste this here and I'm going to click here -1. And that gives me grocery. So grocery is the last element, right? Simple. Now display all the elements. I think this is also quite simple. Oops, sorry. Let me just copy this, paste this here, display all the elements. There are many ways to display all the elements. I think I've similar to string manipulation, products. I can do something like this. I can do print products. Remember, there are 2 colons as well. There are many methods. There are definitely more than this. I'm just showing you. Obviously, I can just call out just products, right? All 3 will give me the same output, right? Again, if I want to display the first 3 elements, right? There are also a couple of ways I can do that, right? I can do a print product 0, starting from 0 until the third element, excluding the third element, right? Until step of 1, right? This is the standard, right? Right, but there's also other methods. Very simply, I can just do something like 0 is default. I can remove 1 here just until 3. I don't even need to have the second one. Still gives me the same value, right? The second colon is auto. I don't need to incorporate it in as well. Okay, assign a list variable products with this again. I'm going to copy this, display the last 2 variables. Okay, how do we do that? We can do, basically print products 3:5, or we can just do 3 onwards. Simple, right? It does the job. It prints the last 2. Okay, negative indexing. You can display the last element. I think this one we had kind of discussed it, right? You can also let's use negative indexing to print the last element. So again, we can print the last element by printing print products -1 until the end, as well as print products. It's better to use -1 because 4 until the end, even though it works in this case, it's kind of not dynamic, right? If the -1 until the end, kind of like it makes it a lot more easier, right? The same with negative indexing, print all the elements except the last element of the list variable product. So how do you do that? Again, let me create product price. All these values, right? Print all the elements. So it's simple. Print product price equals to, not product price equals to, sorry, with the brackets, I'm going to do 0 is to -1. So where you pass in the -1 makes a difference, right? Similarly, prints the elements from the last third index to the last second index. So basically the last second and the last third value, right? So let me do this. And to print this, I'll just copy this, I'll just paste this. So this is going to be -3 until -1, which is 780.9 and 670. Again, similarly, I can also do this if I know that the second element, the second index to the last second index, which also apparently in this case happens to be the same values, because the second index to the last second index is the same two values, right? So just be careful that when you are doing such extractions, right? You can also extract specific elements from a nested list. I think I did this earlier, right? M equals to 1, 2, 3, and then I did 4, 5, 6, and then 7, 8, 9. Okay, just for indentation purposes, it looks better this way. Now display the result of the second element. So you just have to type M, call out 1, sorry, big M, call out 1. Yep. Use a print function, important, right? 4, 5, 6. Okay, a quick practice. List variable product price with all these values. Display the elements from the last third index to the last second index using negative indexing, and display the elements from the second index to the last second index using negative indexing. Okay, try it out. Pause and try it out. Okay, how do we do this? Simple. Product price equals to, we set this. Okay, and then we print product price equals to -3 all the way until -1. Earlier, when we did the example, this and the next answer actually gave us the same answer, but because this time around we have a longer list, we will not just get two elements, and they both won't be the same, right? Until -1, right? So the first one is taking from the last third index to the last second index, -3 to -1. Whereas the second example is looking at second index all the way until the last second index. So when you run this, you actually get 53 and 53.3 to 155, which is these two values, right? But the second index to the last second index is going to take from 7880 all the way until 155. So it's a bit different, right? Something for you to understand. Okay. Yeah. So just some different technicalities we have gone through quite a lot so far today. Hopefully we will be able to understand this when moving on to the next lectures. It will make more sense when we use things like tuples and sets and dictionaries and even NumPy and pandas. Okay, with that said, we've come to the end of today's session. Thank you so much. I'll see you in the next session. Bye.